Hello class, welcome to my guys. Hello guys, welcome to my class. My name is Zahra Rizwandyka, and before we start it, I'm gonna tell you if this video is presented to English for Mathematics final test that handled by Mr. Ahmad, Wafa, Nizami, M.Pd. And I got translation and reflection, which this is the material for second semester on last grade junior high school in Indonesia. Oh, before we start, don't forget to like, comment, and subscribe in this video. And if you want to watch my previous project, you can click link down below on the description box, because I will upload on YouTube even it's for IGTV. That I know like 80% people doesn't like mathematics, but I'm not gonna make you like mathematics for watch this video one times. I just want you to feel comfortable with mathematics, and yeah, I try my best and I make this ASMR, and I hope you guys like it. And without further ado, let's open our lesson by saying Basmalah. Hey guys, welcome to my class. I'm gonna tell you if actually on the transformation there are 4 basic, which is translation, reflection, rotation, and enlargement. These transformations move the shape without making any change to its shape or size. But now I'm just talking about translation and reflection. If you guys want to know about rotation and enlargement, you can check link down below on my description box, because my friends, her name is Hikmah, explain about it. And first, we're gonna talk about translation. In the daily life, we made so many translations. Believe me, for example, if you move from the first place when you're asleep, or a simple thing like move to sit down from right to the left and others. So a translation moves or slides a shape. In this example, the triangle has been translated or moved or slide. Or we can say that the vertices of the triangle A, B, C have been moved or slid to the points A prime, B prime, and C prime. The new triangle called the image has been moved up and to the right. A translation always moves an object, but it doesn't turn it, flip it, or change its size. Each point is moved the same exact distance and the exact same direction. In our example, each point was moved 1, 2, 3, 4, 5, 6, 7, 8, 9 space to the left, and 1, 2, 3, 4 space up. Very important concept for translation is slide the figure left or right. If it goes left to the right, you're going to add or subtract the number from the x value in the coordinate point. And if it goes up or down, you're gonna add or subtract the number of the y-axis or y coordinate point. Okay, now we're going to example. Translate triangle ABC up 2 units and to the right 7 units. Name the ordered pairs. First coordinate A is -6.4, so 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4 up. And then point B is -4, 1, 2, 3, 4, and 7. 1, 2, 3, 4, 5, 6, 7. And last is coordinate C is -2, 1, 2, and 5. 1, 2, 3, 4, 5. And I'm going to connecting them. And this is the triangle ABC. So I want to change it by going up to the 2 and over the right 7. If I go take A and go to the right 7, it's gonna be go over 1, 2, 3, 4, 5, 6, 7. And go up 2 is gonna go over 1, 2 on the y-axis, which will start it right here. So I know that it's going to be 1.6. Okay, new coordinate is going to be here, and my new b, this point is gonna be over here. It's gonna go up 2 and go to the right 7. So 1, 2, 3, 4, 5, 6, 7, and 1, 2. So I know that is going to be 3.9, and new coordinate b is going to be here. Last, for coordinate c, this point going to the right 7, 1, 2, 3, 4, 5, 6, 7, and go over 2, 1, 2. So the new coordinate c is going to be here. And yeah, this is new coordinate. A coordinate is negative 6.4, and the new coordinate a prime is 1.6. B coordinate is negative 4.7, and B prime is 3.9, and C coordinate is negative 2.5, and new coordinate, which is C prime, is 5.7. If you notice, if I want to go up 2, all I had to do was add 2 to each one of this. So 4 plus 2 is 6, 7 plus 2 is 9, and 5 plus 2 is 7. It's same if I want to go over the right 7, I've got to move it 7 place with the x, so with the a, I'm going to add 7. Negative 6 plus 7 equals 1, negative 4 plus 7 equals 3, and negative 2 plus 7 equals 5. So I can either add it to my coordinates or I can do it on the graphs as such. So we got the formula of translation is x prime point y prime equals a point b plus x point y equals a plus x point b plus y. See, it's same. If you get question for drawing the coordinates, you can use manual way, but if your exam has limit time, you can use the formula. Next, we're gonna talk about reflection. Also, in a daily life, we meet reflection. For example, when you look in a mirror, you see a reflection, but you are seeing a mirror image in which everything is opposite. We see reflections all the time in real life. Obviously, we see them in mirrors, but they also occur in water. When a reflection occurs in water, however, it is not a technical mathematical reflection. Why not? Because the image in the water is normally somewhat distorted. It is not the exact same size and shape. So, a reflection flips a shape over to create a mirror image. In this trapezoid, on the right has been reflected or flipped over the dot line to create a mirror image. Or we can say that the vertices of the trapezoid A, B, C, and D has been reflected or flipped over the dotted line to create a mirror image as another trapezoid, having vertices A prime, B prime, C prime, and D prime. Notice that the second figure, which is called the image, is exactly opposite the original figure. Notice that the dotted line is called the line of reflection. It is also sometimes referred to as axis of reflection or the minor line. Can you see how the original point A and the new point A are the exact same distance? 6 units from the line of reflection. The same is true for point B and C's 3 units away, and point D's 6 units away. Whenever a shape is reflected, each side of the corresponding must be the same distance from the line of reflection. Very important concept in a reflection. If you flip over the x-axis, you're going to change the y value to their opposite. And if you flip over the y-axis, you're going to change the x values to their opposites. For example, let's look at the trapezoid before, A, B, C, D, and we're going to reflect it over the y-axis. So I've got trapezoid ABCD of angle A is going to be -5 and 1, B is -2 and 2, C is -2 and 6, and D is -5 and 7. And if I'm going to flip it or reflect it over this y-axis, when I flip it over the y-axis, I'm gonna make the x-axis are going to be their opposite. So if x is 5 here, I know that in this case it's got to be -5 and 1. And point B is -2 and 2. After that, point C is -2 and 6. And then the last is point D is -5 and 7. Remember a very important concept in a reflection. If you flip over the x-axis, you're going to change the y value to their opposites, and if you flip over the y-axis, you're going to change the x values to their opposites. So first, point A prime is gonna be 5 space from the y-axis, and then B prime it's gonna be 2 space from y-axis. Same with point B, C prime is going to be 2 space from axis y, and last is D point, have space 5 from y-axis, and D prime it's gonna be, it means 5 space from y-axis. And this is the result of opposite trapezoid ABCD. Okay, last, I want you to remember about our lesson today. So here I have an octagonal shape. So I want you to determine whether each picture represents a reflection or translation. I'm gonna give you 5 seconds. 1, 2, 3, 4, 5. Okay, enough. The answer is perfect. This is translation because the octagon has been moved or slid. And next shape, we have a square, this orange and this green, and I want you to determine whether each picture represents a reflection or translation. I'm gonna give you 5 seconds. 1, 2, 3, 4, 5. Okay, enough. That's it. The answer is reflection because the square has been flipped over the line. So let's see what you have learned in this lesson. Translation moves or slides a shape, and reflection is flips a shape over to create a mirror image. And there is a simple way to remember. Translation is slide and reflection is flip. Okay, once again, translation is slide and reflection is flip. It's easy, right? Okay, I hope you understand. And yeah, thank you for watching this video. I know it's gonna be like awkward and so weird, and maybe you guys gonna see it. How dare you make an ASMR for a mathematics project? And I just want to make something new, and people in Indonesia call it anti-mainstream. Yeah, I know. I don't know what I want to say. I just want to say thank you and sorry if something wrong in my video. And yeah, we're gonna meet in another class maybe, or another subject. See you on my next video, next weird video maybe. Bye bye. Thank you.